Assalamualaikum warahmatullahi wabarakatuh and hi everyone. Before I start with today's lesson, I need you to have your notes ready in front of you and I need you to have your pens and pencil ready just in case you need to write anything down. Okay? We're going to start off with a new topic today, which is in Unit 1.6, which is called momentum. So this topic serves as an introduction. So we're going to look at the basics of momentum. What does it mean? And how do we calculate momentum? So you probably heard of the word momentum before, especially when you are watching sports on TV. When a team has momentum, it's just another word of saying that the team has an advantage, or the team is on a roll, or the team is on hard to stop. So in football, for example, in American football, and also in our football, which is called soccer in American, when a team has momentum, that means they are at it. They have they're playing well, they are scoring well, so it's hard for them to stop. They are winning. So in physics, it's almost similar like the word that we use in sports, but in physics it tells us about the motion of a mass of an object. In other words, if an object that has a lot of momentum, that means that that object has a lot of motion, a lot of energy in its motion. And if an object has a bit of momentum, then that object doesn't have a lot of motion. So an object that is not moving has no momentum at all. It has zero momentum. An object's momentum depends on its mass and how fast it's moving. So as you can see from this example here, a truck traveling 5 kilometers per hour has more momentum than a smart car at the same speed because it is harder to stop. So an object with a bigger mass has more momentum. That means it's harder to stop. And also, if the object is faster, it's also harder to stop. Now, talking about stopping an object, it reminds us about inertia. So if you remember, inertia is a tendency for an object to keep doing what it's doing. If it's already moving, then the object will keep moving in the same way, in the same speed and in the same direction. If the object is not moving, then it's going to continue to not moving. The momentum of an object is the quantification of inertia. So an object with a large inertia tend to have a lot of momentum. That means once it's moving, it's hard to stop. Or in order to make it move, you need a lot of effort to make it move. And so inertia and momentum are kind of related with each other. Now we can calculate momentum using this equation here that you see. Momentum has the symbol P is equal to m times v. M stands for mass and v stands for velocity or the speed of the object. So from this equation, you can figure out the units of momentum. So as you know, momentum is equal to mass times the velocity. What's the unit for mass? And that is kilograms. What's the unit for velocity? That is meter per second. So the unit of momentum is kilograms multiplied by meters per second, and that becomes kilograms meters per second. So that's the unit of momentum. Momentum is a vector quantity, so direction is important. You can have an object that is moving to the left with a momentum to the left, and an object moving to the right with a momentum to the right. When it comes to writing down and calculating momentum, if an object is moving in a certain direction, you can say it has positive momentum. If it moves in the opposite direction, so whenever an object moves in the opposite direction, then the object will have a negative momentum. Okay? For example, let's say an object moves to the right with a momentum of 15 kilograms per meter square. Okay? And so that's to the right. So we will take this as positive, in the positive direction. So if it goes to the left with the same momentum, for example, 15 kilograms per meter square, to the left, since that direction is in the opposite direction, then we take the momentum as a minus value. That will tell us if it's minus, that means it's moving in the opposite direction than it first started. Let's do an example to calculate momentum. I'll read the example for you. Determine the momentum of a Pacific leatherback turtle of mass 750 kilograms swimming at a velocity of 1.3 meters per second square forward. So you have a turtle that is moving with a velocity of 1.3 meters per second. So this is quite a big, heavy turtle. It weighs quite a lot, 750 kilograms. So let's calculate the momentum of this turtle. So what's the formula of momentum? P mass times the speed or velocity. What's the mass? 750. What's the velocity? 1.3. And that will give you 975 kilograms meter per second. And don't forget to write down the direction for this momentum, because momentum is a vector, and in this case the momentum is also in the forward direction. So to summarize, what is momentum? Momentum tells us about the motion of an object. A heavy object will have a larger momentum. A lighter object has a smaller momentum. A fast object has a large momentum. In other words, it's harder to stop. And a slow object has a small momentum. So the definition of momentum, you can get it just by looking at the formula of momentum. P is equal to m times v. So the definition is similar. Momentum is the product. So product is just another word for multiplication of mass and velocity. And the unit for momentum is kilograms meters per second. And that's the end of the first part of this lesson.